Hey everybody, Dr. Hasanalu here. How you doing? My voice is going, so I'll try to be as quiet and calm as I can to give this video so I don't lose it anymore. But things seem to be progressing well. Good work, everybody. There was some confusion about the quizzes and what they are, testing. Needless to say, I'm just trying to make sure you're doing the work, and I arrange them so that you can't use AI to get the answer. So, the point of the class is to teach you how to think for yourself and get that ability and gain critical thinking skills. And AI does the exact opposite of that. Don't get me wrong, I think it has its use, but you can't rely on it too much. And so, you're just going to have to do the minimal amount of work, reading the chapters and watching these videos. Although if I'm saying this to the people that are not watching the videos, it's kind of self-defeating, isn't it? Because they're not watching this either. But those people are not going to do well in the quiz. So we're going to do chapter 3 now. And it's a pivotal chapter. So you might have thought, with the two phases of argument analysis, the reconstruction phase and the evaluation phase, that a natural place to start would be with the reconstruction. But quite the opposite. We're going to actually start with the scientific portion of it, if you will, the mathematical portion of it, dealing with evaluating the arguments. And the first sort of things to talk about with evaluating the arguments. So I have some slides here. Um, the three ways an argument can go wrong are if the premises are, uh, even if they're true or reasonable, that they do not sufficiently support the conclusion, if the premises are false or known to be unreasonable, or both, right? So if I say, you know, all dogs are mammals, uh, Fluffy is a mammal, and therefore Fluffy is a dog. Suppose that I have a cat named Fluffy, right? Well, then, even though it's true that all dogs are mammals and Fluffy is a mammal, it does not follow, right? It's not a good argument to say that Fluffy is a dog because merely being a mammal doesn't provide enough relevant support, given that all dogs are mammals, to conclude that Fluffy is a dog. Um, Fluffy could be any number of different kinds of mammals other than a dog. And again, supposing Fluffy is a cat, both of these premises would be true, but it's still a bad argument. So that's an example of that, right? And what if I say, fish are mammals, flounder. I don't know if you guys get that reference. If not, I'm depressed. Flounder is a fish, therefore, flounder is a mammal. Now, these premises, were they to be true, would provide enough support for this conclusion, but they're false because all fish are not mammals. So this is a case where the premises are known to be false or else not known to be reasonable. We'll get back to that difference later. That'll come up in a later chapter, right? This is just sort of giving you the general lay of the land. And then if I said something like all fish are mammals, flounder is a mammal, therefore flounder is a fish. That would be a case of both. So uh, even if these premises were true, they do not sufficiently support the conclusion, right? And they're also, the premises themselves are known to be false. Okay. So the chapter that we're going to discuss is going to focus on this one, where we're not evaluating individual premises and whether they're true or false or reasonable, but we're evaluating whether or not the premises, even if true, do not or do not support the conclusion. Okay. And the key notion there, a lot of discussion in the book, is this notion of validity. So let's move to that. So this is a very tricky notion for students. I'm just sort of flagging that, but I'm going to try to explain it to you in a way that avoids those confusions so that you are clear on what it is versus it isn't. Okay. So what we're doing is we're checking to see whether the explicitly stated premises, when assumed to be true, guarantee the conclusion of the guarantee the conclusion. Okay. Uh, so that means the conclusions do not follow as a result of any hidden assumptions. And in order to determine the validity, we only need to know the meaning of the logical terminology. What the logical terms mean is irrelevant. Okay, so let's just sort of examine this idea. Maybe I'll put this up in my workspace. Okay, so if I go to all dogs are mammals, the sort of the going one that you love, um, my dog is a Annie, my dog is a dog, or Annie is a mammal. This argument is valid. And the reason why the argument is valid is that assuming both of these premises are true, this has to be true. Okay. There's a way of sort of picturing that. I'll try to like show it, right? So if I have here's the mammal or the dog circle and then draw around it a bigger circle for the mammals. That would be a way of picturing the idea that all dogs are mammals. Apologies, I'm not good with the technology enough to do this. I mean, I could try with the drawing of the circles here. Let's do it. So there's one circle, there's the other one, right? And so right here, dogs, pigs, and up here, mammals, right? So all dogs are mammals. Cool, it kind of keeps it with that, right? And then if I put Annie as a dog, right? So there's Annie. She's in the dog circle, in other words. It's like a terrible version of a Venn diagram, right? Well, then you can actually see how it has to be true on this given information that Annie is a mammal. So that's what makes it valid, is that assuming the premises are true, the conclusion has to be true. The thing that makes it valid then is the way that the information is arranged by the meaning of the logical terminology. Okay. So just to make it a point, if I were to say Annie is a dog, right? Then all that would tell me is this. Here's the dog circle again. And then here's Annie inside the dog circle. On that given information, do we know that Annie is a mammal given just this piece of information that Annie is a dog? Can we conclude on that piece of information alone that Annie is a mammal? No, because on this information, we have nothing, no information about the relationship between dogs and mammals. So that's the tricky part about validity. You have to sort of suspend your background knowledge in order to determine validity. So even though you know that dogs are mammals, it's irrelevant for determining validity. Instead, you have to just look at the way that the information is arranged according to the meaning of the logical terminology. So what the hell does that mean? Well, so if I go back, right, and I say, dogs are mammals, mammal circle again, right? So the terms that matter for determining validity are this word, all, that's a logical terminology. That's a piece of logical terminology. Are, here's a phrase, is, that's a logical terminology, is, right. So these are what determine validity alone because these words arrange the information in a way that allows us to assess whether the truth of this guarantees the truth of this or not. Okay. So if I were to say all fish are mammals, Annie is a fish. Therefore, Annie is a mammal. That's valid. And the reason why it's valid is because I assume that this is true. All fish are mammals. And so then now you see my wonderful circles here. Here's the fish circle, and here's the mammal circle, right? And so I just pictured that piece of information there. And then Annie is a fish. Well, I put Annie into the fish circle, right? And it follows that Annie is a mammal, right? So that's why this argument is valid because assuming the truth of this and the truth of this has to be true. Okay, let's do a different example. So if I say, no cats are happy, Annie is a cat, and therefore Annie is not happy, that is also valid. Now, so how would I picture that piece of information? Something like this, right? I'd say, well, no cats are happy. So let's just go down here, do the same thing, right? So how would I picture no cats are happy? Well, I would draw two circles and I wouldn't have them overlap in any way whatsoever, right? So here's the cats, and here's all the happy stuff, happy things, happy animals, right? So I've pictured that no cats are happy because I pictured the fact that anytime there's a cat, it's definitely not over here with the happy stuff. So Annie is a cat, so there's Annie. So we can see again on that piece of information that this is a valid argument. So again, the reason why I use that example is, I'm sure, I don't know, are cats happy? I don't know. Cats seem usually like aloof, but I imagine there's happy cats, of course. I mean, I'm not a cat person. I'm more of a dog person. So even though this is false, that is irrelevant for determining validity. All I need to know is the meaning of this word, and this word, right? And the word not, right? And then that tells me what it means to be valid. So you have logical terms like you can keep a list if you like, all, some, not, are, is, 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 and so on, right? So those words are what determine validity. So you can another way of thinking about it is that what you have here. So if I go back to that example, all dogs are mammals. Annie is a dog. Therefore, Annie is a mammal. These words give it a kind of structure because they arrange these pieces of information in a certain way, being a dog and being a mammal. So one thing that we'll do is we'll just replace the words that are there with letters, like algebraic letters, to indicate the structure of the argument. So if I say X is an A, X is a B. So I hope you see how that, I mean, it's not that hard, right? That has the same structure as, where is it? No, I got rid of it, right? The earlier one, okay? As all dogs are mammals, Annie is a dog, therefore Annie is a mammal. So that structure is depicted by this, except for I would say A now, and B is up here, right? This is the B circle up here, and then X. Okay. So that is the sort of important move. You'll see in the book, uh, right around this page, what is this? Page 85, for example, and there are others. You have these, he uses P's or Q's. he has things that just have the, see that either or, that's another term. And then the squiggle here is a word for not, right? So they give structures of valid forms. So one of the things I would do is when you do the problems, like this one, and you're gonna have to do these this week. If you like logic, then you love debate. You love debate, therefore you like logic. Is I would put first give the structure of that. So let's see if I can do that one real quick. You, if you like logic, then you love debate. So what would be the structure of that? So again, here's some logical terms. If, then. So we can add that to that list up here. Remember we had either or, if, then. Again, it's sort of anything that like arranges the information in a certain way such that you can assess the relationship between the truth of the premises and the truth of the conclusion. So what would be the structure of that? Pause the video. What would be the structure of that? It'd be something like if A, then B, B, therefore A. Is that a valid argument? No. And one of the reasons why is that you can just memorize if you want that this is a invalid structure. But what you can do in order to test for validity is once you get the structure, plug in values with things you are more familiar with, and then you can oftentimes just notice the fact that it doesn't follow. So my favorite example, what I would plug in values for A and B that are more familiar. So if it's a dog, then it's a mammal. It's a mammal, therefore it's a dog. See how that is just a sort of particular example of this? Well, we already have examples where this is true and this is true and this is false. What if I have Fluffy in front of me? So that would be a case where this is true and this is true and this is false. And as long as we can come up with one case where this is true and this is true and this is false, right? Then that shows that it's not valid because in order for the something to be valid, the truth of the premise has to be guaranteed. So if we have one example where it doesn't follow, it's not guaranteed. Okay. So that's the sort of move I want you to get good at is taking arguments, getting them into that structure where you use just the logical terms and if and A's and B's, and then assessing their validity. You can either just memorize the patterns, do it that way, okay? Or you can look at uh, particular examples of it that are more intuitive and do it that way, right? I mean, the only other tricky thing about that is that, if it was this way, right, this would be valid, right? Because then I would say if it's a dog, then it's a mammal. It's the dog, therefore it's a mammal. So, one of the things I would do is to ensure that it's valid, I would picture this piece of information, okay, and check that way. And the way of picturing that information is just the same way as this, right? If it's a dog, mammal. If it's a dog, then it's a mammal. Oh, right. Oh, that's kind of cool. Okay, so if you hadn't figured out all A are B, X is A, X is B, another way of saying that is this. That argument and that argument are structurally equivalent. Okay, so you have different tools here. You're given the argument, just to sum up what I'm getting at. When you're given a practice problem, I would first put it in its structure. And if you want to determine that it's invalid, I would try to find an example of an argument with the same structure where it's sort of already something that you recognize, where this is true and this is true and this is false. And we just did that before with the dogs and mammals, and then Fluffy is a mammal, therefore Fluffy is a dog. Then you know it's invalid, right? Another thing you can do is when you have an argument give it an instruction. And if you think it's valid, try to picture the information along the lines I did before, where you draw the circles for if thens or alls, or and so on and so forth. And I'll leave it to you to sort of do that in more complicated instances like this, right? And if the picture shows that the conclusion has to be true given the premises, you know, as this one does, like you again, like you can just see how if I say all dogs are mammals, X is a dog, it has to be true that X is a mammal. Well, then you know it's valid. Okay, so that's how that works. The only other thing it talks about, which is important, is cogency. So we can move to that. Cogency is the same thing as validity, except the premises make the conclusion likely to be true. So if I go something like this, most cats have four legs. Fluffy is a cat. Fluffy has four legs. This is not valid because assuming it's true, and it is that most cats have four legs and that Fluffy is a cat, it's not guaranteed to be true that Fluffy has four legs. Because what if Fluffy's one of those three-legged cats? I mean, I had one in grad school. We called it tripod, right? I don't know what happened to tripod. We had to get rid of it because it pissed everywhere in my house. But going back to the example, this is a cogent argument. Nevertheless, even though it's invalid, because the truth of this does not guarantee the truth of this, the truth of this makes it like guarantees that the conclusion is likely to be true. You know, if I go back to my room example, right, where go over in the room, I have a bunch of cats, and most of them are four-legged. You know, there's some tripods hopping around in there. Well, if I pick a cat at random, then hold it 99 out of 100 times, let's say there's 200 cats and two of them are tripods, right? Then 99 out of 100 of those times it's going to be a four-legged cat if I just pick it like random. Imagine one of those like games that you can get at like restaurants where it's like the claw. It just picks a cat up by random. Well, if I had one of those, 99 out of 100 times it's going to be a four-legged cat, but there's going to be two or one out of 100 times where it's going to be a tripod. So that shows that although this is not guaranteed to be true, it makes it likely to be true. Okay. So the nice thing about cogency is that there's really only one form, and it's something along these lines. I mean, he like needlessly complicates it in the book, but if you have an argument and you know that it's invalid, you could say, well, is it cogent? As long as that argument doesn't have a form like this, you know it's not cogent either. So it's just a bad argument. Again, he has all this terminology, just a bad argument. So another variation of those, something like this, nearly all, right? Something where the truth of this shows that the probability of this uh, example having that is above 50%, then it's cogent, right? So that's the move. I was sort of drawing it all together. If I was given an argument and I wanted to determine whether or not it was a good argument, at least in this sense of a good, where we're just going back to whether or not the premises sufficiently support the conclusion. We haven't talked about this yet. Okay. But if I was just assessing it for this sense, what I would do is take it, put it in structure, determine if it's valid. If it's valid, wonderful. If it's invalid, then as long as it doesn't also have something like this structure, then it's not cogent. And then it's just a bad argument in general. But if it does have this structure, then you know it's cogent. Does that make sense? I hope so. Okay. So that was a longer video. You're gonna have to put all that into practice, but hopefully that gives you a foundation for understanding validity, and you're gonna have to do some practice problems and learn it that way. And if you cheat your way through it, you're just gonna cheat your way through the exam too, then you're not gonna learn anything. And I don't really give a crap if that's how you want to do it, but you're not going to be really helping yourself You could challenge yourself a little bit because this is actually a very easy concept if you put in that time and that thought to critically think. All right, take care.